Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the first law of thermodynamics and some thermodynamic quantities. Previously, we discussed some common thermodynamic terms, including intensive and extensive properties, and spontaneous and non-spontaneous processes. We learned the properties of a system can be intensive or extensive based on whether the properties depend on the amount of substance that is present in that system. Processes can be spontaneous or non-spontaneous, depending on whether or not they require external energy to continue. In today's lesson, we will explain internal energy and heat in relation to the concept of thermodynamics. Shall we start? The internal energy of a system is the total energy that is contained within a system. Part of the energy is kinetic, and part of it is potential. When chemical systems change from reactants to products, and the product returns to the starting reactant, the internal energy changes. In order to determine the change in energy, we measure the difference between the system's internal energy before and after the change. In other words, we measure the final internal energy and subtract the initial internal energy. The kinetic energy part of internal energy is made up of different types of molecular motion as well as the movement of electrons within molecules. The potential energy part of internal energy is determined by several factors. The attractive and repulsive interaction between molecules, the attractive interactions between electrons and nuclei within molecules, the repulsive interactions between electrons within molecules, and the repulsive interactions between nuclei within molecules. Students, let us do an activity. In a moment, you will see several sentences related to internal energy. Please read the sentences carefully and fill in the missing words. Also, list the factors that determine the potential energy part of internal energy.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I'm sure that you had no trouble with this activity. The internal energy of a system is the total energy that is contained within a system. In order to determine the change in energy within a system, we measure the difference between the system's internal energy after the change and before the change. The kinetic energy part of internal energy includes different types of molecular motion as well as the movement of electrons within molecules. For the final answer in this activity, the factors that determine the potential energy part of internal energy are the attractive and repulsive interaction between molecules, the attractive interactions between electrons and nuclei within molecules, the repulsive interactions between electrons within molecules, and the repulsive interactions between nuclei within molecules. Were you able to list all of those factors? If so, you have a great memory. Let us move on with our lesson and discuss heat in relation to thermodynamics. Heat, or thermal energy, is the energy that is transferred between a system and its surroundings as a result of a difference in their temperatures. In other words, heat moves spontaneously from regions of higher temperature to regions of lower temperature. When a system and its surroundings reach equal temperature, the transfer of heat ceases. At this point, the system and its surroundings are said to be at thermal equilibrium. An exothermic process is when a chemical reaction or a physical change releases heat. An endothermic process is when a chemical reaction or a physical change absorbs heat. Students, please list 2 examples of exothermic processes and 2 examples of endothermic processes. You may begin now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I wonder what examples you thought of. As we discussed, an exothermic process is any reaction that gives off heat. A couple of examples are a burning match or water that is freezing. Endothermic processes absorb heat. Therefore, ice melting and the process of photosynthesis are good examples. The absorption of heat is necessary for these reactions to occur. Great work, everyone. The SI unit of heat is Joule, but a calorie is also a unit of heat. Calories are the amount of heat that is necessary in order for the temperature of 1 gram of water to be raised by 1 degree Celsius. 1 calorie is equal to 4.184 joules. The temperature change that different substances experience is dependent upon their heat capacity. Heat capacity is the amount of heat energy that is required to raise a substance's temperature by 1 degree Celsius. The heat capacity for 1 mole of a substance is called its molar heat capacity. It is important to note that in all thermodynamic calculations, temperature must be expressed in Kelvin. To calculate Kelvin, add 273.15 to the degrees Celsius. The heat capacity of 1 gram of substance is called its specific heat. Here you can see a table showing the specific heat for a number of common substances. In order to determine the specific heat of a substance, we can measure the temperature change for a known mass of a substance that gains or loses a specific amount of heat. Students, a 466 gram sample of water is heated from 8.5 degrees Celsius to 74.6 degrees Celsius. Calculate the amount of heat absorbed by the water in kilojoules.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. All we have to do is place the numbers that we know into the equation that we just learned for specific heat. As previously discussed, to change the temperature from degrees to Kelvin, add 273.15 to the degrees Celsius. Thus, 273.15 plus 74.6 degrees equals 347.6 Kelvin. The specific heat is equal to the quantity of heat transferred divided by 466 grams times, open bracket, 347.60 Kelvin minus 281.5 Kelvin, close bracket. We can rearrange the equation to find the quantity of heat transferred. Thus, the specific heat times the amount of water times the temperature change equals the amount of heat that the water absorbed, which is 129 kilojoules. In today's lesson, we learned about internal energy and heat in relation to thermodynamics. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.